For generations, astronomers have dreamed of seeing another world the way we see the planets in our own solar system. Not as a tiny signal hidden inside a graph. Not as a faint shadow passing in front of a distant star. But as a real place. A planet with its own sky, its own atmosphere, and its own story waiting to be uncovered. That dream seemed impossible for a long time. Then everything changed. For the first time in human history, the James Webb Space Telescope captured a true image of a planet orbiting another star. It wasn't just another scientific milestone. It was the beginning of an entirely new era. But that first image raised an even bigger question. What if the strangest discoveries were still ahead? As Webb kept searching, it revealed worlds that challenged almost everything scientists thought they knew. Planets with impossible chemistry. Atmospheres unlike anything predicted. Giant worlds sitting where they shouldn't exist. And one distant planet that may hold the strongest clues to alien life ever detected. Each new observation seemed to replace certainty with mystery. The deeper Webb looked into the galaxy, the stranger the universe became. And one discovery, in particular, captured the attention of scientists around the world. That planet is called K2-18b. Before Webb studied it, K2-18b was simply another distant super-Earth. It was larger than our planet, incredibly far away, and almost impossible to study in detail with older telescopes. Few people expected it to become one of the most debated worlds in astronomy. But when James Webb turned its powerful mirrors toward it, something extraordinary happened. Instead of collecting only basic measurements, Webb peeled back the planet's atmosphere layer by layer. Hidden inside was a thick blanket of hydrogen surrounding a world that may contain an enormous global ocean. Imagine an ocean so deep it could swallow mountains without leaving a trace. That alone would have been remarkable. But the atmosphere revealed even more. Water vapor appeared clearly in the data. Then came methane. After that, carbon dioxide. Everything seemed exciting but still within the realm of possibility. Then scientists noticed one more molecule. And that's when the conversation changed completely. The molecule was dimethyl sulfide, often called DMS. On Earth, this chemical is produced almost entirely by living organisms in our oceans. At first, researchers questioned the result. Could it be an error? A glitch? Random noise? They checked again. Then again. The signal kept appearing across multiple observations. No one rushed to claim they had found alien life. Scientists are careful for a reason. But they also couldn't ignore what the telescope was showing them. Could this distant ocean world actually support living organisms? If life exists there, it probably looks nothing like anything on Earth. Sunlight would struggle to pass through the thick atmosphere, creating a dim and endless twilight. Beneath those clouds could be vast oceans where simple organisms slowly evolve over millions of years. They may follow the same basic chemistry that created life on Earth, yet become something completely unfamiliar. No one knows the answer yet. But one thing is becoming clear. Among all the planets we've studied so far, K2-18b may be one of the strongest candidates for hosting life. But as astonishing as that sounds, another discovery would prove that nature can be even stranger. When James Webb captured one of its first direct images of HIP 65426b, astronomers expected to find an ordinary gas giant. Massive planets like Jupiter are common enough. They follow familiar patterns. At least, that's what everyone believed. The image told a different story. HIP 65426b is nearly 7 times more massive than Jupiter. Even more surprising, it orbits extremely far from its star. According to the standard models of planetary formation, a giant planet shouldn't be able to grow in such a distant location. There simply shouldn't be enough material available. Yet there it was, shining in the darkness as if the rules no longer applied. But here's where things became even more puzzling. When Webb analyzed the planet's light, the atmosphere refused to behave normally. Scientists found unusual chemical layers, unexpected temperature changes, and cloud structures that shouldn't remain stable for long. Instead of looking like a calm gas giant quietly circling its star, the planet appeared disturbed, almost as if it carried the scars of a violent past. How could that happen? One theory suggests the planet formed around another star before being thrown into space during a chaotic gravitational encounter. Millions of years later, it may have been captured by its current star. Another possibility is even more incredible. Perhaps it spent ages wandering through interstellar space as a rogue planet before finally finding a permanent home. There is no definitive answer yet. But every explanation forces scientists to rethink how planetary systems evolve. Maybe our own solar system isn't the standard example after all. Maybe it's the exception. That realization transformed Webb's first exoplanet image into something much larger than a beautiful photograph. It became evidence that the universe creates planets in ways we still don't understand. And the next world on Webb's list would remind us that even our closest neighbors can keep their secrets hidden. Only a little more than 4 light-years away lies Proxima b, the closest known exoplanet to Earth. Ever since its discovery, people have imagined standing on its surface, looking back toward our sun as another distant star in the sky. Because the planet sits inside the so-called habitable zone, many hoped it might have oceans, clouds, and perhaps even life. It seemed like the perfect destination for humanity's dreams. But reality turned out to be far more complicated. Proxima b orbits so close to its star that James Webb cannot separate the planet's faint light from the overwhelming brightness of Proxima Centauri itself. The star completely hides the atmosphere researchers desperately want to study. We know the planet is there. We can estimate its mass and orbit. Yet we still cannot truly see it. Why does something so close remain so mysterious? The answer lies with its parent star. Proxima Centauri is a red dwarf famous for violent solar flares. These enormous bursts of radiation may have stripped away the planet's atmosphere long ago. Even if oceans once covered its surface, they may have disappeared billions of years ago. If any atmosphere survived, the planet may be locked with one side facing the star forever while the other remains trapped in endless darkness. Only a narrow strip between blazing heat and freezing cold might offer conditions where liquid water could exist. Proxima b reminds us that distance alone doesn't determine whether a planet can support life. Sometimes the closest worlds remain the hardest to understand. And while one nearby planet hides behind the glare of its star, another distant world shocked scientists with chemistry they had only imagined before. That world is WASP 39b, a giant gas planet orbiting so close to its star that its atmosphere reaches incredible temperatures. Astronomers expected a simple environment shaped mostly by heat. Instead, Webb discovered one of the richest atmospheric chemical signatures ever seen. The telescope detected water vapor, sodium, potassium, carbon monoxide, methane, and sulfur dioxide. That last molecule changed everything. Sulfur dioxide forms through chemical reactions driven by intense starlight. Scientists had predicted such reactions for years, but no telescope had ever observed them happening on another planet. Webb captured the first direct evidence of active photochemistry beyond our solar system. Even stranger, the balance between these chemicals didn't match existing models. The atmosphere behaved like a giant natural laboratory filled with reactions researchers still cannot fully explain. Every answer created another question. If chemistry can become this complex on one of the hottest planets ever studied, what might happen on cooler worlds with oceans and stable climates? Not every discovery brought excitement. Sometimes Webb shattered long-held hopes instead. Few planetary systems generated more optimism than TRAPPIST-1. 7 Earth-sized planets orbiting a single small star. Several of them located inside the habitable zone. Many believed this system would become the best place to search for life beyond Earth. But the telescope revealed a far harsher reality. When Webb studied the first 2 planets in detail, it found no atmosphere at all. Not even a thin layer of gas remained. Their rocky surfaces sit fully exposed beneath relentless radiation from their star. Without an atmosphere, they cannot trap heat, protect water, or support the complex chemistry needed for life. A system once imagined as a possible paradise suddenly looked cold, hostile, and barren. Although disappointing, this discovery taught scientists an important lesson. A planet can appear perfect from a distance while hiding a lifeless reality. Habitability is far rarer than many had hoped. The right size and the right orbit simply aren't enough. Many invisible conditions must also come together. But if so many promising worlds fail to meet those requirements, what does that say about life across the galaxy? As James Webb continues exploring distant planetary systems, one pattern has become impossible to ignore. The Milky Way is overflowing with planets. Some are scorching hot. Others are frozen solid. Some may contain endless oceans. Others are wrapped in thick clouds unlike anything found in our solar system. Everywhere we look, new worlds appear. Yet despite this incredible abundance, none has provided undeniable proof of life. Scientists keep finding atmospheres, storms, water vapor, and complex chemistry. They discover conditions that resemble early Earth. But the final piece of evidence remains missing. The universe seems filled with places where life could exist, yet it stays remarkably silent. Is life incredibly rare? Or are we simply searching in the wrong way? That mystery grows deeper with every new observation. James Webb has already transformed our understanding of the cosmos. It has revealed ocean worlds hidden beneath hydrogen skies, giant planets occupying impossible orbits, nearby neighbors concealed by violent stars, and atmospheres filled with chemistry no one expected to find. It has replaced assumptions with evidence and reminded us that nature rarely follows our predictions. For the first time in history, these distant planets are no longer just mathematical ideas or tiny points hidden in distant starlight. They have become real places with real atmospheres and real histories written into the light reaching Webb's mirrors. Every new image, every spectrum, and every unexpected signal brings humanity one step closer to answering one of the oldest questions we've ever asked. Are we alone? No one knows when that answer will finally arrive. It could appear in the next observation. It could emerge from a faint chemical signature hidden inside another distant atmosphere. Or it may come from a world no one has even discovered yet. Whatever the future holds, one thing is already certain. James Webb has opened a window that can never be closed again. Beyond that window lies a universe more mysterious, more beautiful, and more surprising than anyone ever imagined. And somewhere among those countless worlds, the greatest discovery in human history may already be waiting.